In this section, we're going to learn about the way of assembling a decorative serial lamp set for 240 volts AC using 6 volt bulbs as well as the flashers. The lamp filament operates at a very high temperature of 1800 degrees centigrade to 2200 degrees centigrade. The resistance is nearly 12 times more when the lamp is on than when it is off. Now, let's see how to calculate the resistance. If the voltage is equal to 240 and the wattage is equal to 60, then current is equal to wattage by voltage, which is 60 by 240, which is 0.25 amps. Then the resistance is equal to voltage by current, which is 240 by 0.25, which is equal to 960 ohms. Similarly, if the voltage is equal to 24 and wattage is equal to 40, then the current is equal to wattage by voltage, which is 40 by 24, which is equal to 1.667 amps. Resistance is equal to voltage by current, which is equal to 24 by 1.667, which is equal to 14.4 ohms. When we have to connect a row of 6 or 9 volt lamps, if the lamps are connected directly to 240 volt supply, the lamps will get fused immediately on lighting. Therefore, the lamps have to be connected in series. If the voltage of the lamps are 6 volts, then the number of lamps that will be required are 240 by 6, which is equal to 40 lamps. And this is how the lamps are connected in series. We get bulbs of the same voltage but different current ratings in the market. It may be 100 milliamps, 150 milliamps, 300 milliamps, or 500 milliamps. To assemble a serial lamp set after determining the number of bulbs required based on the voltage of the bulbs, connect the holders in series with suitable lead lengths. Test all the bulbs and fix them in the holders. Connect the lamp set to the main supply and test them for their glow across the 240 volt supply. Switch off and now add a flasher bulb in series and check its working. With the flasher bulb connected in series, now the series lamp set should flicker. Please note that for the series lamps to work satisfactorily, the current rating of all the lamps should remain the same. But we can have serial lamps of different voltages but of the same current rating connecting together. Let's assume that we have 25 lamps of 6 volts and 20 lamps of 9 volts, all of 300 milliamps rating. Now, to design a serial lamp circuit for 240 volt supply, this is how we proceed. If we want to use all the available 6 volts bulbs, the voltage drop for 25 lamps of 6 volts in series will be 25 into 6, which is equal to 150 volts. Deducting this from the 240 volt supply, the voltage remaining to be dropped is 240 minus 150, which is equal to 90 volts. The number of 9 volt lamps in series is equal to 90 by 9, which is 10 lamps. So, 25 numbers of 6 volt lamps and 10 numbers of 9 volt lamps can be connected in series across the 240 volts mains. Alternately, if we want to utilize all the 9V lamps, then the voltage drop across 20 numbers of 9 volts lamps is 20 into 9, which is equal to 180 volts. Voltage to be dropped by 6 volts lamps in series is equal to 240 minus 180, which is equal to 60 volts. So, the number of 6 volt lamps in series is 60 divided by 6, which is equal to 10 numbers of 6 volt lamps. So, 20 numbers of 9 volts and 10 numbers of 6 volts can be connected in series across 240 volt mains. It is always safe to keep the number of bulbs in series more than the calculated numbers. This is to reduce the current through each lamp slightly. The reduced current decreases the chance of fusing of the lamp when the voltage of mains is increased by chance. Now, let's see the use of the flasher and how it is connected in circuit. The flasher lamp contains a bimetal strip which is in contact with a fixed strip. When the serial lamps are switched on, the bimetal strip gets heated up and breaks the contact, disconnecting the supply to the chain of lamps. Again, when the strip cools down, it regains contact and the lamps light up again. 3 rows of lights connected with 3 flasher bulbs, as shown here, operating at the same time can produce a twinkling effect of the lamps. In case one flasher is to be connected common to the 3 rows, then the current carrying capacity of such a flasher in parallel circuit should be equal to the total current drawn by the parallel circuit as shown here. Though the flasher can be connected anywhere in the circuit, it is advisable to connect it near to the supply, considering it as a switch. This is the basic principle on which a serial lamp set is assembled.